to the respective buckets. And here in 4, which is the internal node before as well, and 41 is where I'm going to add my new records. So it is split up into 2 nodes, and now 41 becomes an internal node, so it is changes from square to circle, and my external nodes are now 41, 410 and 411, which is pointing to the respective buckets. So we can see when we compare both the efficiency of dynamic hashing and extendable hashing. In dynamic hashing, everything grows very gradual. Now in the case of extendable hashing, you can tell always the growth is doubled. Okay, why do it happen? We have steps like, we have mainly 2 steps in extendable hashing. We try to create a tree, then we try to complete the binary tree, and then we go for creating the directory. Okay, when we go for creating and complete binary tree, we try to double the changes all throughout the tree, which creates a doubling effect. So that is the difference between a dynamic hashing and extendable hashing. We don't have this doubling effect in my dynamic hashing, where the doubling effect does not come here. Every growth is very much gradual. So what is the process of finding a key in dynamic hashing? We mainly have 2 steps. The first one is we need to know which is the original address from where I need to start searching. Now I start searching from the first address. I keep moving till I find it. Now where is the search? I search till I find the external node, which is equal to my key which is searched. If it is not an external node, we have to keep searching till it reaches an external node. That is what the condition. If directory node, external node and points to a bucket, the search is complete. Means the key is matching to a node, and if that node is an external node pointing to a bucket, then the search is complete. If the directory node is an internal node, again he needs to keep moving till he reaches an external node which is pointing to a bucket. Okay, so that is what we have, these 2 conditions here. And the second step is how to find the key inside that particular bucket. Always the keys are saved inside my bucket. So we can tell that the key is actually used as a seed for random generator, and it produces 1s and 0s. As you already see, 2 is generates 2 external nodes like 2, 0 and 2, 1. Similarly, it is produced and the keys are saved inside the bucket. And this sequence of generate is actually describes the path throughout the tree. Okay, by using these 2 steps, we are able to identify the addresses and the respective key from the tree. Now we see the differences between a dynamic hashing and an extendable hashing. In the case of dynamic hashing, the extended directories are linked structure. As you already see, it is already linked from the parent till the child and to the bucket. It is linked. Okay, now in the case of an extendable hashing, it is a perfect tree. There is no linkage that when you compare, but you can tell that it is having an array structure which is used for representing the directory. Okay, so we can tell in the case of extendable hashing, we are having an array structure, and here in dynamic we are having a linked structure. Now it allows for slower, more gradual growth of the directory, and in the case of extendable, a directory is doubled. As we already see, only necessary items are being added into my dynamic hashing, but in the case of extendable, we try to double it for balancing the tree. That is where we double the effect. Now in the case of dynamic hashing, it holds pointers to the children, and because of that, this much of spaces are required when we load the tree into the memory in the case of dynamic hashing. But in the case of extendable hashing, that much is not required, but if at all it is not accessed or a page fault happen, we will be able to access it within one page fault, because lot of memory is not required in the case of extendable hashing. Now in the case of dynamic hashing, it uses link structure which increases our page fault because we are using directory structures. Now the main common thing which we have here is both the dynamic hashing and the extendable hashing are using same space utilization. So the next technique is linear hashing. So linear hashing was found by Letwin in 1980, and here we are using more bits of hashed values as the address space grows. So when the address space grows, we are using more bits. Okay, now we are having in this example we are going to understand linear hashing with the help of an example. We are having 4 buckets. Okay, that is instead of 4 directory nodes, we are having 4 buckets. Okay, and we are trying to add new records into each bucket so that we understand what happens when that particular bucket overflow. Okay, so what actually happens means here, even if a bucket which is in the address space is overflowing, always the extending happens linearly. So consider that here I'm considering I'm having an overflow in bucket B, but I'm having buckets A, B, C, D in a series. So whenever, even if I'm having bucket B overflow, bucket A will be the first one to be extended. Okay, and it is bucket A which shares the overflowed records within it. Okay, so we'll see with an example so it is much more understandable. So here we are using a 3-bit hash function h3 of k for dividing the records, and here we see the example. This is our example where we are having 4 buckets A, B, C, D in the respective addresses 0, 0, 0, 1, 1, 0 and 1, 1. Here we are having a case where I'm having an overflow condition for B where the overflowed records are saved inside a bucket named W. Now when this happens, what actually happens means the in linear way I'm going to extend my in linear hashing, I'm going to extend my buckets linearly. So the now first time it is bucket A which have to extend. So I'm going to split A into 2, A and A. Okay, and I'm going to share the records inside my W within A and A. So this is what happens when I'm having an overflow condition first happen. So we go for the next overflow condition where the second time I'm having an overflow condition in bucket D. Now we have just extended bucket A, so the next chance come for bucket B. Even if I'm having an overflow condition for bucket D, the next one to be extended or to be divided as bucket B. So bucket B goes with the division and shares the overflow records of X within B and B. So the next example is again I'm having an overflow condition with 2 buckets X and W. In the sense I'm having more records to be added with overflow over my D. I'm having records in X and Y. Now what happens? Who is the next? A has extended, B has extended. The next one to be extended is C. So now C is divided into C and C, and X and Y overflow records are divided within C and C. So this is what happened. So next thing which happens is I'm having an overflow condition in Z. So A, B and C is over. Now it is D. Now D is divided into 2 and Z overflow records are divided within D and D. So this is how linear hashing works. So we can tell once a series of divisions or extension is over, we go for the next hashing function, that is h4 of k. So far we were using h3 of k. So once one round of extension of a particular set of buckets are over, in the next set again the pointer will be pointing to bucket A, where the hash function used will be h4k. So this keeps going until we have an overflow condition happening. Once an overflow condition is ended, this overflow condition or this extension also ends. So this is how our linear hashing works. Thank you.